Hello friends, in this video we will talk about LLMOps. You might be hearing this term whenever you encounter with any LLM system, or if you want to develop some application which is using LLMs, large language model, then definitely you might have heard about this term. So let's decipher what it includes, what are the different technologies and that we can use to cover the LLM ops, and understand what are the different parts when we say LLM ops, what we can do. So let's start with what it means. It is basically LLM operationalization. You might have heard about this term DevOps, right? If you have worked in the software engineering. Then came LLM ML ops for the ML machine learning models. And then now, because LLM is all pervasive, all people are trying to use and leverage the power of LLMs. When we build the application using LLM, so this term is become important. Let's see what is DevOps. It is operations, enabling operations for developers. That means what a developer will do, they write code, they fix bug, and then they push their code in some branch, they run some test cases. If the test case pass, then this will be deployed to a particular branch, let's say me. We also call a CI/CD pipeline, continuous integration, continuous delivery. So whatever code changes the developer is doing, it will be merged to a branch. It will run some test cases to validate whether those uh, code have fixed the bug or have not broken the other functionality to, or causes a regression. And once that is done, then it can be merged to a main. And all this is automated. And the pipelines can be much longer depending on the what level of controls that we want in our CI/CD pipeline. But developer operation is much bigger. This is just one part of the DevOps. Other part could be how to maintain different versions of the code, different branches. What about the documentations? How we are publishing the release notes. So all that aspect comes under the DevOps. But mainly from a developer point of view, CI/CD pipeline is one. But with the advent of machine learning, what happened? The pipeline got changed. It has a different types of requirement. So if you see from the machine learning angle, it has some data. It has its own model for the code. And here I am talking about traditional machine learning or even neural networks, but not of the size which now we have of LLM. So basically here we are training a model from scratch. That means model is just some code and for now, and then data, and then the training process happens, and then the final output comes, which is a final model. It can be further deployed to, let's say, main branch. So if you see how we can version control, there are multiple pieces. The data can change, hyperparameters of model can change, the training process when happens, then model again can change if we do a second iteration, and we need to maintain this model and its version which is deployed. And again, the test some test cases, basically the evaluations, and there are different types of evals that we run for these models. So the pipeline which is created to manage the machine learning operations, any project of machine learning operation, these are the MLOps. But the story changes when LLM came. What is the difference? If you try to see the difference, with LLMs, these are very heavy neural network, right? That means, yeah, pardon my drawing. So it's a very heavy neural network. Now, and this is also trained on a huge amount of data. That means that this data can be in GBs and multiple GBs. So consider all the internet data, different works. We have LLM, we have VLLM, vision related LLMs, which understand the images and all. So there are huge amount of data. The training cost is very huge. We are not in regular application. We are not training the LLM on our own. We generally use some pre-trained models. So what are these pre-trained models? It is already trained on a lot of data. We use this type of models to build our application. If required, this pre-trained model can be fine-tuned. Fine-tuned on a specific amount of data. So whatever the operations which were applicable for ML ops, because of being in training from the scratch, not all of these are applicable in LLM ops, but it applies in case of fine tuning. It applies once the model is trained, then it need to be evaluated. So those evals, because there are major problem with the LLMs is about hallucination and different techniques that came to reduce this hallucination. One could be fine tuning, one could be using the RAG. Right? Now even GAG. We'll talk about maybe in separate video about these aspects. But let's see from the ML ops perspective, you need to have some data if you want to pre-train a model. You will pre-train your model, not sorry, pre-train, fine-tune a model. Because here we are talking about application building, LLM ops. If you want to pre-train a model, that's a huge task, and I think in that case, the LLM ops type of things will work. But when we are building some applications using LLM ops, there is a different approaches we need to pick. So if you see for fine tuning, we should have some data, not that much of data which is required for training a fundamental model, basically this pre-trained model. It is already trained and we are using transfer learning approaches here. Right? So this is one of the use case. Other use cases, once a model is trained and we are using the application, we need to evaluate whether it is serving the purpose what it is built for, or how we evaluate the performance. Because of being probability in nature and it's very hard to predict every time, so we need to have certain evals. Now in the evaluation, if you see what is required, a data, right, on which our model will run, right, then it will produce some results, and these results need to be validated um, along with the expected output, and these expected output are created along with the data, whatever the data and whatever should be the output. And after models run a processing on this data, we try to see whether the results, which is this result and this expected output, are matching. And because it is a language based output, so simple comparison will not work. We need to use LLM again, but as a judge, right? Which will see the similarity score between these two. Basically, there are different ways of looking at similarity, different types of mathematical functions. It's a topic in its own, but in this video we are talking about LLMOps, so let's stick to it. But if you see the process, we need to have the different data sets, different versions of data set. Similarly, the expected output, the models. Here in this model, what can change? Either it can be a pre-trained model, uh, simple pre-trained model with proper prompts. Right? Also, we are doing some prompt engineering, so we need to maintain those set of prompts. And whether we see if we use one particular prompt for one set of data, what is the quality of the output that we are getting when compared to the expected output. So we may want to have different versions of the prompt also. And so there's a pre-training, or there can be a fine-tuned model, or even different types of pre-trained model. For example, OpenAI has multiple models. O4, sorry, for 4O, GPT-4o type of model, or reasoning models like O1 series or O3, O4 mini, which has recently came out. Likewise, we have Gemini. So if we want to, let's say, test out our application with these pre-trained model provided by some of these providers, and want to see in which part of the prompt that we are getting good results from which model. So all these things we need to maintain a different versions. And this is all about LLMOps, because if we maintain these different expected results, we can run some experiment. Then I think we will be able uh, to run um, these experiments and see what is the quality, and then we can deploy those prompts in our production. And also in the production we can have some evaluations with some traces, not all, to keep monitoring whether our output is uh, fluctuating or it's on the point, or there may be a concept of drift in the ML. So there may be a cases of drift given the type of data which is coming in. So let's talk about um, from an angle how a typical application is built with from dev to prod. Right? First, we have to build whenever we are building an application on LLM, we need to identify what LLM that we retrained LLM, whether it's a ChatGPT LLM or Gemini LLM or Cohere, or you have your own um, trained or any open source. There are a number of LLM models which we can use. From there, we have our prompt engineering. Here, what we do, we write few prompts to see whether we are getting the expected output. And with those prompts, we have our evaluation results, evals. And if we are satisfied with evals, there are basically from the eval results, like we can have the two paths. Whether it's a improvement that we need to make from here, and if it is yes, then what we can do, for from the improvement for the part one which we are getting, we can either go for some fine tuning a model, or maybe some other types of transfer learning like RLHF, human in the loop, using the reinforcement learning, human in the loop, um, or um recently there are different variants which came as part of the human in the loop process. Like recently GRPO, if you have heard about, uh, when DeepSeek came, has created a storm in the LLM community, which is actually based on the reinforcement learning reasoning model that we are calling. So those type of things that we can do here, we can have some data. A team can create some specific data, or we can basically have some fine tuning. For fine tuning, actually, we need some data. Okay. So if this is the case, then we will fine tune a model. And once fine tune a model, then again it will go to the eval process. Right? Let's say again we came here. Is there any room for improvement we need to make? Let's say this time we don't need it. So we can deploy this to prod. Right? Here again we can do some evaluations, not all instances, but to some instances. So we run the eval and try to see whether there is a there is some improvement in the quality or not. Right? Okay. So once we are on the prod, there are different way we see what to use. Whether use A/B testing for different prompts, different models, right? Or when we are deploying these new models, we can do specifically different techniques for deployment, like canary deployment. That means we deploy only for 10% of uh, request the new model and evaluate those results, and if are on par with expected output, then only we will further deploy for other servers. And there can be some other type of deployment which is called blue green deployment. That means we will completely flip and deploy a new model for all the users altogether. Right? This is how generally any project who is doing uh, building an LLM application will need to make sure they have these systems in place, so that their application is robust and they can understand and have some observability. Let's talk about what are the tools are available for these type of things. So there is a open source platform called Kubeflow. it helps you to build these pipelines basically to track different versions, different models, run evals, and check the results. So all these pipelines can be built in Qflow. Similarly, there is a product called MLflow, and even the latest, like we have the Langsmith, which is basically created by LangChain. Here it has all the pipeline and all the repository for different types of data set. We can track different experiment. We can see the results of experiment and prompt versioning. So all those stuffs which these platforms provide and which we can manage very easily. So let me know what you are building with LLMs. I think it's a very uh, cool technology which is emerging, and it can be considered as the electricity of the present day. For example, when the electricity came invented for the first time, from there on, if you see how the human race has evolved so fast, has built so many different types of machines, so many innovations to improve the life of the people. Similarly, I think LLMs is going to do that shift in the building of technologies and different products and services, and making uh, better world life. So whatever you are building, let me know. If you have any question, I'm happy to answer. Please let me know your questions, your doubts in the comment section of this video. I'll be happy to respond to those. Thank you. With this, I'll take a leave. BK from Anika. Thank you.